Hello, everyone. Hope, your dog. That's a beautiful picture.
Thanks. It's my sister's boyfriend's roommate's dog.
Oh my God, that's complicated.
Yeah, it is complicated.
You know the name of the dog?
Millie.
Millie, that's a good name.
Yeah.
I bet it's part
She-
lab. It looks labbish.
Yeah, she is so sweet, and she actually has a tic disorder, so she ticks all the time. She's just so cute.
Oh, well, cool. Cool. That's a nice picture of you. All righty. We're putting our phones away, right? Have you taken a picture of me yet?
Of you?
Bring it up here. Bring it up here. You get a picture of me. Don't make it happen a second time, because there'll be both of us.
Thank you.
There's only like 50,000 pictures floating around of me.
There's no bell.
What was the first time you ever took a selfie?
Me?
Yeah.
In this class or?
Yeah, like what year did you implement the selfie rule?
Oh, 2-3 years ago. Yeah. So, and then obviously people wanted selfies right away. So they all had their phones up. So, hey, Abyssers, how are you? So, I could feel I love the word, William, I like the word angst. It's one of my favorite words. I could feel the frustration ebb through my body last night of the vibes you were sending. And I got a lot of texts and emails. That's all cool. I'm going to go through that and tell you, first of all, I'm going to tell you my philosophy on giving some stuff, and then I'm going to go through it. Okay? Everybody got that? Alrighty, I'm going to do that now. And then tomorrow, I'm going to go through that other sheet that the 2 assignments you're supposed to go. So I'm going to have to figure this out. Oh, I got to take roll first before I get any further. Sorry about that. Alrighty. Let me take roll here. Raina talked. Zach, are you here?
Yeah.
Caleb, I see. Gabe, I've talked to. Lily, are you here?
Here.
Lily, you sound tired.
I'm fine.
Are you fine? Okay. Tucker Grayson is gone. Oh, he's doing the ACT also? Okay, Karina?
Here.
Gibbs? Gibbs?
Sorry, I clicked on the wrong thing again.
Would you repeat what you just said?
I said I clicked on the wrong thing. I accidentally clicked on my
Okay.
emoji thing.
Okay. William, I've already harassed. Sophia, are you here?
I'm here.
Jaden, are you here?
Here.
Morgan?
Here.
Jordan?
Here.
Audrey?
Here.
Audrey, has anybody told you that your first name and last name might be the most beautiful combinations of names? Audrey, Josephine, that's beautiful.
Yeah, my mom liked the name Josephine, but my father wouldn't let it be my first name.
Yeah, oh, but man, it's really cool. Yeah, and Hope, it's is here. I talked Hope already. All right, good. So what I'm going to do is talk about that secant activity. I'm going to hit save here and close out of this and tell you what I was looking for, okay? Because, and I'm looking at them. Well, I didn't look at you, what you guys put in because I'm just getting caught up now, but I'm going to show it at first. Alrighty, so let me get it up here. Well, let's take a long time, computer. Alrighty, let me share my screen with this. And I'm going to try doing it this way. Perfect. Share. And okay, I'll go here, this group. And it should start working over here. Maybe. Yeah, now we got all funky. So you guys can see this screen. Am I right about this?
Yep.
Okay. And so one of the first things you had to do is, I believe I told you how to change this green equation, right?
Yeah.
And so you had to click on it, and I think you had to type in negative x squared. Am I right on that? Was that the first one?
Yeah.
Mhm.
And what that did is it changed it into a parabola, and then you had to change a, correct? And I think I plugged in 2, and then I would plug in 2 here. Jordan, does that look correct?
Yeah.
Okay. And let me get this down here where I can see them. There's an H somewhere up here too. There we are. Oops. And then there was that awful worksheet that caused a little bit of frustration. So the idea is this: as you decrease H, these points A and B start moving to A. Would you agree with that? Okay. So this is, I'm going to share with you another screen, hopefully. Come on, can I stop sharing? What happens if I do that? Oh my God, look at this. Doesn't that look terrible? Holy buckets. It's the slope of secant's document. So I'm going to tell you what I was looking for. If you didn't do it, I'll tell you how I scored it. First of all, those points are moving. Oops, I probably should share this with you. Where are you guys? Because my screen gets all wonky. I mean, it's like too large. So I gotta go to edit, start share, and this one. Where did it go? Bottom left, you think so? Right here? You guys can see this now? Oh, not now. Can you see it now? In the a bit, Jordan, you can?
Yeah.
So what I wanted to see in here was as you move those points together, you're moving closer to 2, correct? And you had no idea what those x's are, so I could have made stuff up. I could say this is 1.9, oops, 1.9, 1.99, 1.999, right? And I'm approaching 2 from the left. And over here, I could type in 1.001, or excuse me, 2.01 and 2.1. And then I can manipulate H, get it smaller and smaller and have some different values. Now, does it mean those numbers matched up with those slopes? Not necessarily. But the idea is that I'm getting closer to 2 as I'm from the left and the right, and that I'm headed towards a particular slope. If you were confused and left those blank, I'm not making an issue about it. I'll give you credit for that, okay? But what I did look at is when you did do that and looked at the slopes, you should have come up with a -4 for that one. And when I did the next one, you should have came up with a -4 for this one. And so that's what I'm looking at. I'm looking at what you got for slopes. And on this next one, you should have gotten 1. That's what it's approaching. The next one is a little bit more difficult. I saw a lot of people write a -0.7, which was correct. I would be okay with that. This one, you should have gotten, I think, a -3, I believe. And then the last one, what you're going to find out is in one of these columns, you got 1, and the other column, you got a -1. Am I right? That it didn't change no matter what you moved, those were the values. We're going to hopefully talk about that today. So the slope of this, because it was not merging to one number, I needed to have does not exist as that answer. Are we okay with that? Okay, now here's my philosophy. I do not teach you how to do every problem. I assist you in getting the skills that you can think through and get the problem. And so I'm trying to develop a little bit of creativity because when you take the AP test, I know what type of problem you can get. I don't know what the problem will be. So I have to create a skill set in which you're a problem solver for any type of problem they throw at you. So that's where I'm coming from, okay? So I am sorry about causing you the frustration. Will it change? Probably not. Okay. But I mean, it's my way of getting you, and I know there's still people out there that, Raina, are you a perfectionist? Sure? Okay. You like being a perfectionist? I think it's hard to be a perfectionist. So anyway, I'm sorry that there was a lot of frustration on that part. Any other time you're frustrated and it doesn't have to deal with math, you can just blame it on me. So, if you stepped in some dog poop, you can just say, that's Kruger's fault. I'll be okay with it. Any questions from the Abyssers at all? We doing okay? Okay. All righty. I need to do this. And I need to do this. And you need to get your notes out. Oh, and I'm going to tell you this right up front. Since you guys, there's a certain amount of suffering that was going on, I'm moving the quiz to Friday. That means your textbook homework won't be due till Friday. Everybody okay with that? Or is there somebody that really wants the quiz on Thursday? Gabe, do you want the quiz on Thursday?
No.
You sure? What? William, is that okay, or were you looking for a quiz on Thursday?
That'll be fine.
That'll be fine.
I think I want 2 quizzes.
Who said that?
Me.
Gabe? Gibbs said that? Gibbs, I'll give you a special.
Yeah, my last quiz wasn't the best, so I need to pick it up.
I'll give you one. Alrighty. I'm gonna sneeze. Oh. So I got, my God. So, can you guys see this? Can you see my hand?
Yeah.
Okay. Does it have an Asian beetle on it right now?
Yep.
You know they bite? They're not ladybugs, they're Asian beetles. Don't give them, they're not ladies, I'm gonna tell you that. They are mean. God, I got bit by them yesterday. And they can handle strong winds. I don't know how it is. They just hang on to you. Oh. Well, anyway, I got a couple of questions for you. And let me get a list of participants here. What? Yeah. Well, no, this is me thinking out of the box. I live out of the box. No, I decided against the pop quiz. Audrey, you ready?
What's up?
Did you just say what's up?
Yep.
Oh, we have some lights up above me. Suppose. Audrey, how do you do this problem? I'll give you this function. And I want to know its derivative. Do you think you could figure out the derivative?
Let's hope so.
Okay, what would it be?
Is it 15x to the 4th?
You said that so quickly, and it's correct.
Okay.
Isn't that nice to be fast and right at the same time?
Oh yeah.
Okay. Karina, are you ready?
Yeah.
Does that look like a 5?
Yeah.
Does that look like a 3?
Mm-hmm.
What is its derivative? And I can give you a hint if you want.
Yeah.
Yes, you want a hint? You want a hint?
Sure.
It's a lot easier if you rewrite this. The coefficient is 1/5. Do you see where I get 1/5?
Mm-hmm.
And then x, and this is the cube root in the denominator. What exponent or power does it have?
1/3.
Almost 1/3. It's in the wrong location for it to be 1/3 though. If this was above, it'd be 1/3, but because it's in the denominator, it's something else. Because it's location, it's in the opposite place.
Negative.
Negative 1/3, okay? Was that helpful for you to take the derivative?
Yeah.
So what do we get?
Would it be a negative 1/15 x?
So far, it's perfect. Now you gotta figure out the power. And what are you gonna do? What are you trying to do?
Subtract 1 with a
Subtract one.
exponent.
So this is the way sometimes I think of it. If this is helpful, Karina, I think, okay, on the number line, I'm at a negative 1/3, and I want to go to the left 1 unit. Where does that put me?
Negative 4/3.
Perfect. Very good. Okay. Yep. So you guys got the process, right? So, Audrey, if I have this, A is some constant, some coefficient, X, and N is some power. How would you express the derivative?
So the derivative is a times n x and to n minus 1.
Holy buckets. Yeah, that's it, isn't it? Right? Slick. All right, let's go back to the notes. Oh, you should know this. This is notes that I would write down. It says finding the slope of a tangent line. Another name is derivative instantaneous rate. There are two ways. Before we just learned our shortcut, is that we can take the limit, and this is when we know x equals c or we know a point. This is the definition of a derivative using a limit. And this is the other definition, knowing the limit. I am going to have to step out for a second because my nose is. All right. Oh, it feels really good. It just wakes you up. Oh my gosh. It's better than taking a shower. Put hand sanitizer. Shave your head first. You can't have hair like that. It won't make any sense to you. Shave your head and then rub hand sanitizer on it. Oh, wow. Whew. It's better than a cup of coffee. All righty. And so then this is the general one, correct? Okay, so let me show you something. I would add one more thing to this. I'm going to call this 3. So if I had as an example, the limit as x goes to 2 of x cubed minus 8 over x minus 2, that's going to be the same as the derivative of f with 2 in it, correct? Would everybody agree? This thing right here is f, right? Because of that. The derivative is 3x squared. Oops, with x, correct? So this has to be 3 times 2 squared, which is equal to 12. So this has to equal 12. So I don't have to factor anything. I just have to identify what this is. Let me give you another one, number 4. If I have the limit as delta x goes to 0 of x plus delta x to the 4th minus x to the 4th over delta x, that has to equal to the derivative of x, correct? Right? This right here is f of x, correct? That means this answer has to be the derivative of x to the 4th. Right? So Tucker, what is the derivative of x to the 4th? 4x to the 3rd. Bingo. So I could give you something really complicated here, correct? William, is that making sense?
Yeah, that does. Yep.
Okay, so William, I'm going to give you one. Ready?
All right. Yep.
What's that equal to?
What's what equal to?
This limit.
The limit, it's f to the f, the derivative of f, so f prime 3.
What is,
Right.
yeah, f prime of 3. So what is f prime of x?
F prime of x. It's
What's f?
f of x is x to the 4th minus x squared plus 9, right?
Correct. Yep. And I haven't
Okay.
talked about this yet, so I'm out there. If not everybody's seeing that, don't worry, you'll see it again. So f is x to the 4th minus x squared plus 9. And if I plug 3 into there correctly, this should be 72. 81 minus, actually I did it wrong. This should be 81.
Mm-hmm. Okay.
I did my math wrong. Because when I put 3 in here, I would get 81 minus 9 plus 9. Well, that's 81. So what is the derivative
Of
of this right here, of this function?
do you have to factor it?
No. What's the derivative of x to the 4th?
So that's 3, no, that's 4x to the 3rd
Yeah. Minus, now take the derivative of that.
minus 2x. Yeah,
Yeah.
minus 2x.
And then take the derivative of 9.
It's just 1. No, it's 0. It's
0. Okay. So now you're going to plug 3 into here. And this
Okay,
means
so 27
times 4
times 4 is 108
minus, what is
minus 6 is 102.
102. That's the slope of your tangent line. It's a lot better than trying to do synthetic division, right? Okay. All right, back to your notes. All righty. So these are just problems that I gave you. Why can't I? There we go. And so Jaden, if I gave you this, f of x equals 7 over 5x squared, okay? Tell me what that is in what that function is in power form, Jaden. What's my coefficient? You're not taking the derivative yet.
All right, so 7/5 x -2.
Perfect. So now take the derivative. Jaden.
So -14 over 5 x to the power of -3.
Perfect. Exactly. Okay. Lily. Let's have 8 the 4th root of x cubed. Put that in power form for me.
Um, sorry, I'm like confused on the square root.
Okay, well, it's not a square root, it's the 4th root. Do you see
Or the
my
fourth.
4 right here?
Mhm.
So it's going to be x, 8x. So the 4 here, the index, that's going to be the denominator of the fraction. Anytime you see this radical,
Mhm.
whatever is here is going to be in the denominator.
Okay.
So the 4 will be here, okay?
All right.
Whatever you see here, that's going to be in the numerator,
Okay.
okay? So what is the derivative then?
Um, 6x to the
Perfect.
um, and then what would I do for the 3/4?
Well, can you envision a number line?
Yeah.
Okay, so put yourself at 3/4 on the number line and go to the left 1 unit. Where does that put you?
Um,
Right? You're going to be past 0, correct?
yeah.
Okay, and to get to 0, that would have been 3/4, right? And you got another 1/4 to go, correct?
Right.
So, and I'm past 0, so where am I going to be at?
I know like what you're talking about. I just can't.
Okay, so if I'm to the left of 0, oh, let's do it this way. Let's do it this way. Let's say you got 3/4 in your pocket
Mhm.
and you're buying something from me that costs $1.
Mhm.
And so you give me the 3/4. Okay. You're short, right?
Yeah.
How much?
Um, like if I gave you like the
Okay, you
three,
give me the 3/4 and you say, hey, this is all I got, and you owe me $1. How much are you short?
I'm sure at 1/4.
Yeah, you're short 1/4. You owe me a fourth, correct?
Right.
So mathematically, we write that as a -1/4. You're 1/4 in the hole.
Oh my gosh. Okay. Thanks. Yeah.
Okay, does that help?
Right. Yeah.
All right, good. Yeah, stuff just comes back. I'm going to pick Morgan Schreifels. Morgan, you ready?
Yeah.
And I want to do this. I'm kind of in the mood for this. Let's have 15 over the cube root of x squared. Tell me how to write that in power form.
Would it be 15x to the 2/3 power
Almost.
or the negative 2/3 power?
Yeah. Okay. And this is for everyone. When you have these, when x is in the denominator, its power is automatically going to be negative. Okay. All right, so let's take the derivative. Morgan, what do you get?
Would it be a 10x to the negative 5/3 power?
I have a negative 5/3 is correct. The 10 is almost correct. What are you missing on the 10?
A negative sign.
The negative sign. Perfect. Very good. Very good. All right. I think we're going to stop there, and we're going to go through some of these notes. And this is a typo. This should be x right here. It says the constant rule, the derivative of any constant is always 0. That's what it's saying. So, Caleb, if f of x equals 7, then its derivative is equal to what? 0. That is the nicest thing. That's as much work as you need to show. And then right here, I have the power rule. I like it better if it's this. I think, I forgot who did this for us in class. Sorry. That this derivative is going to be the product of a and n, and then x to the n minus 1. So it's always multiply, subtract 1, multiply, subtract 1, multiply, subtract 1. So, Sophia, how are you?
I'm good.
You're good?
Yeah.
So f of x equals x. What's the derivative of that? You want me to give you a hint?
Yes,
I'm
please.
full of hints today. This is a 1, and that's a 1. So you're going to take 1 times 1, and then you subtract 1 from 1.
So it's just 0.
No. Where did you get 0? How'd you get 0?
Well, you just said subtract 1 from 1.
Right. Well, what is 0? The what is 0?
The derivative of f of x.
They're laughing here because my desk started moving. So this exponent becomes 0, correct?
Yes.
Our answer isn't 0.
So then it'd be 1.
1 is correct. Okay. Very good. Hope. dy over dx is another way to say the derivative. What is it if f of x equals x to the 4th?
X to the third,
Yep. What's the coefficient in front?
4.
Perfect. 4x to the 3rd. Exactly correct. Okay. Next page. You know what? I don't like this. I just did this with the last class, and I don't know why I don't ever change this. So I'm going to cross this out. I could do that because when you're old, you can do whatever you want to do. So
Mr. Kruger, sorry, could you go back to the last page just so I can take a quick picture?
yeah. This whole page.
Yeah.
Okay, so I should back up a little bit. I don't know if I can get the whole thing in there.
Or you could just move it down. I just need to get the power
Like
rule.
this part.
Okay, perfect. Thanks.
Okay, good. Super. All right, so we're going to change the function. We're going to have All right, so it says find the slope of the tangent line using this function. So the first thing I'm going to do is take the derivative. And Gabe, what's the derivative? Let's back up a little bit, okay? Let's write this in power form. What is the power form going to be? X. No, the coefficient here is 2. 3 over 2. Yeah, I wish they would put a 2 in here. They don't, and I think that messes people up. Okay, so now let's take the derivative. Just 3 over 2. Okay, and then x to the 1/2, which is the same as 3/2 times the square root of x. Would you agree with that? So the slope here of the tangent line, and I'll write it as dy dx, just so you see something else, would be 3/2 times the square root of 2. Would you agree? What would it be here if x equals -1? What do you think? Right. In this class, we don't deal with I, so we don't. So what would your answer be? You are correct. You can't. Bingo. Very good. Very good. In this class, not having an answer is an answer. Does everybody understand that? And it's going to be clear in a little bit. It's going to be clearer in a little bit. And let's keep going. Gabe, now we're going to have dy dx. What do you think it's going to be here? We got 4, and there's our derivative, right? What do you think it is? Perfect. And you did that quickly without a calculator. Awesome. Okay. Everybody got that? Besters, we doing okay? All righty. The equation of the tangent line. So I've shown you this, correct? Right? Zach, what 2 things do you need to have for a line? This is the second day I brought this up.
The slope and a point on the slope.
Perfect. Slope, point. Zach, which one do you want to do first?
I guess the point.
Okay. We know our point is a -2 comma something. Would you agree with that?
Yeah.
How do I figure out the y value? How do I figure out the number that goes there?
You insert -2 for f of x, right?
Yes, beautiful. That's exactly. So I'm going to take a -2 and cube it. So a -2 times a -2 times a -2.
-8.
-8. Awesome. So I know now, I know this part. X minus a -2 plus a -8, correct? That's my point slope form, correct? So how are you going to figure out slope? What do you need to figure out slope? You want me to give you a hint?
Yeah.
The derivative of f. In other words, what's f prime of x?
That would be 3x to 2.
Correct. So now we're going to plug that -2 into there, correct? In other words, we're doing this. We're doing f prime of a -2. The purpose of the derivative is to give a slope of a tangent line. What is it when you square -2 and then multiply it by 3?
12.
I think you said it and I misunderstood.
12.
12. 12 is correct. So that's what it looks like. And you're done. Now, somebody like Raina Berry may say, that's not good enough for me. I need to have that like this. And that'd be okay. Raina might even go further and say, I need to know the y-intercept. I don't know why she would need the y-intercept. She just likes y-intercepts. It makes her sleep well at night. I don't know. I would stop there because I'm not Raina Berry. Because she has hair and I don't. She doesn't use hand sanitizer on her head. I do. Okay. Now, the equation of a tangent line. Notice right here, when this -2, this is C. Does everybody understand that that's C? That's our special X value. So, Caleb, this thing here is the slope, right? It's the derivative with 2 plugged into it, correct? So I can write this as f prime of C. Does that make sense? And this right here, there's my -2 right there, wasn't it? So that's x minus C. So when I plug C into f prime, that gives me slope. And when I plug C into f, that gives me that y value. That was that -8. So this is now the point slope form in calculus. If you choose to take BC calculus next year, we'll call that a Taylor polynomial of degree 1. And it's really cool. And that's where we get e to the I pi power plus 1 equals 0. Ever see that? The greatest equation of all time. E to the I pi power plus 1 equals 0. That is on my headstone. My name might not be on it, just that. And everybody else will have to figure stuff out. All righty. Zach, excellent, excellent, excellent. Let's see. Gibbs, you get to choose 1, 2, 3, or 4. Which one do you want to do?
1.
Okay. So let's write, this says y prime is another way to say the derivative. So let's write y in power form. It's 5x to what power?
-6.
Well, look at it down here. I think that's a 1 right there.
Yep. Hang on, let me write this down.
Yeah, let me make it bigger. Does that look out of focus to you? Looks out of focus to me.
Is it just the -2?
Well, it's going to be a -1 to begin
Yeah.
with,
Yeah.
correct?
So it's gonna be -5x to the
Right.
-2.
And you got to be, guys, got to be careful. When you rewrite it using powers, that's not taking the derivative. You got to do, once you get it there, you got to multiply, subtract. You got to do those things. So rewriting it doesn't create the derivative, which is a mistake I made a lot. It's just, I'm just getting the numbers to know what to multiply and what to subtract 1 from. Say, Gibbs, you want to pick somebody for
Hold on,
me?
Kruger.
Who?
Kruger, wouldn't that be a -5x to the -2?
Oh,
Yeah.
yes, it would be. And I think Gibbs told me that and I forgot the negative sign. Thank you, Jordan Smith. So Jordan Smith, since I have you on the phone or on the monitor, we're going to figure out the derivative of f. Tell me what this is in power form.
2x to the -1/2.
And then what's the derivative?
-1 or -x to the 3/2, -3/2.
Perfect. Which I could write like this, right? Correct?
Yeah.
Okay. God, it's let's just do one more. Let's do number 3. And Karina, you want me to give you a hint, or you think you're ready to go?
I think I'm ready to go.
All right. So dy dx again means derivative, right? You're okay with that?
Mm-hmm.
What's that got to be equal?
So it would be 35x to the 4th on the top
Yep.
over 16.
Perfect. You're done. Is that nice?
Mm-hmm.
All righty. Let's take a look at these. And William kind of got this last time. Now I have a series. So what you're going to do is take the derivative of each of these individually. So William, the first term is going to become what?
That's gonna be 4x to the third.
Perfect.
Yeah, that was my problem last time. I didn't know you could take the limits individually of each term.
Yep, you can.
Okay.
Yep. In fact, we did that with limits, that we say, okay, we're going to take the limit of this, we're going to take the limit of this, we're going to take the limit of this, and then combine those answers at the end. And I'm glad you said that, because even though you're taking derivatives, since the derivative is defined as limits, that's what we're doing to come up with this using.
So yeah, because it's the limit of the secant line, right? That's why we can take each individual term.
Yep, exactly correct.
Okay.
So what's this next term then?
So that's it's just -3.
Perfect. And then what about the last term?
0.
I don't have to write 0, do I?
No.
That's kind of like a pointless act. If people write 0, I'm not going to mark it wrong, but you don't have time to write 0. Just move on, right? Okay. No, I'm going to have Lily. Lily, let's try this one. G prime of x. So I want you to, again, like William, take the derivative of each of these separately. Okay, so you're going to do this one first. What do you think its
Okay.
derivative is?
Negative. Because -6. Having a brain fart, sorry.
No, that's already, I have a lot of those.
Okay, would it be -2?
Yes, it would be. X to what
To
power?
the 5th power.
Perfect. Now you're going to move on to the next term.
Plus 8x.
Perfect. Now this one.
Would that be 1 or would that be 0?
Oh, it's 1.
1. Okay.
Because it's a variable.
Gotcha. And
Okay.
then -11 would be 0.
Correct. Correct. Now we will be taking what's called the second derivative. Okay, we're not going to do it today, but we'll take a derivative of a derivative, and then that one would become 0. Does that kind of make sense?
Yeah.
Okay, and then this would become 8, and this would become a -10x to the 4th. Are you okay with that?
Mm-hmm.
And I can keep doing that. I could have the third derivative, the fourth derivative. Okay. All righty. Very, very, very good. All righty. Now let's take a look at some functions that aren't sine and cosine. If you notice, it says the derivative of sine, that's what this means. The derivative of sine is cosine. The derivative of cosine is a negative sine. Let me show you some graphs. And so I'm going to have to go into the abyss somehow. I want to get rid of this thing. Come on. I'm going to have to use a calculator. I'm going to use the calculator instead. It'll work just as fine. You guys can see my calculator, right?
Yeah.
Okay, let me get it up so I can see it, because I can't see it. There we go. All right, so I'm gonna go here. Oops, I want a graph. Delete this. And I'm gonna type in the sine of x. And I am going to make my window from negative pi, positive pi, and I'm going to go from -2 to 2 just to give myself a little room. And I'm going to draw. So that's sine, right? Okay, everybody have that? And then what I'm going to do is, and I can also show you this on a TI if you want me to. I have my TI here. Maybe it's in my bag. So on a Casio, you have something up here that says G solve. So what I'm going to do is I'm going to exit here and I'm going to go shift G solve. Oops, delete. Oh, you're not letting me do that. Exit. Exit. Maybe I could do it now. Shift G solve. All right, what do I want to do here? Huh. All right. I think I want to do this. I want to go to options, go to calc, take the derivative of the sine. So I'm going to go now to vars. I'm going to choose y1, and then I'm going to choose x. So this is taking the derivative of this. Okay, so the blue line is the sine curve. And you look at this curve, it looks just like the sine curve, but it's been shifted 90 degrees, right? Pi over 2. Okay. And so that's why cosine got its name. It's really the sine curve shifted 90 degrees. Cotangent is really the tangent curve shifted 90 degrees. Cosecant is really the secant curve shifted 90 degrees. Okay? So you could see that this is the cosine, so the derivative of derivative of sine is cosine. And I'm also going to do the proof here in a bit. Yeah, I'll show you. And I'm going to type in cosine. I'm going to do the same thing. I'm going to draw. So now my blue line is cosine, and this looks like sine, but it goes in the opposite direction. So this derivative that I'm graphing is negative sine, okay? I could do that with any of them. Let me come up here. Let me put this thing in. Let me put in x squared. There's x squared. There's its derivative, 2x, correct? That's the equation 2x. It makes sense that's 2x, doesn't it? Okay. All right, let's see if I have. I do. Let me show you how to do it on a TI. So I'm going to type in the sine of x to begin with. Make sure you're on radians and not degrees. Okay, everybody got that? Then you go to math. And I'm going to go down to line 8. And what that does, it says n deriv, correct? That means numerical derivative. So I press that, and now it's into y2. Does everybody have that? Everybody okay on that? Caleb, you okay on that? So now I'm going to go to vars. I'm going to choose y var's function. And one of the choices I can get is y1, which is what I want to take the derivative of, okay? So I press enter and it says y1. Then I'm going to follow it by a comma, which is above your number 7 on my calculator. And then I'm going to type the variable x because I'm telling the derivative I wanted you to figure out the derivative for all x. Or excuse me, I want you to figure out the derivative in terms of x. Then I'm going to have another comma, and I'm going to type in x. Casio people don't need to do that. So it should look like this. Can you guys see it okay? Is that better? Everybody got that? Marina, you got that? Okay. Yours looks a little different, I bet. Okay. Does yours look like mine did? Did it look like this? Yeah. So what you're going to do is you're going to put y1 into here. Okay. And you know how to get that, right? And then I think there's a blank right here. Type in x here using your variable x. And then there is an equal down here and you have to type in x. So you got to put y1 here, x and x there, okay? Does that make sense? The old Casios, they're doing the same thing, but they're separating by commas. Does that kind of make sense? Then I go to my window and I go from negative pi. Otherwise it gets really funky. I don't like it. To pi. And then I go from -2 to 2. Because if you go from -1 to 1, it's too small. You need a little space. And then hit graph. Now my TI will take a long time. So there's sine. There's cosine. Yeah. I don't think theirs will take as, I think their processors are a little bit bigger. But we'll do some things, you'll go, oh my God, you think your calculator has died and you're going to wait a few minutes before it kicks it out. This thing, like, bam. Okay. But what's nice now is I can come back here and I can change it to whatever I want. I could put x squared in there and graph the derivative. Still takes a lot of time to think. But does that make sense why that's 2x? Okay. That makes sense? Okay. So let me show you the proof for this. Okay, and what I'm going to do is I'm going to do the proof for this one. And probably by the time I'm done, then since I'm moving the test to Friday, I'm going to give you a little bit of notes tomorrow. Okay, and so Thursday may be the work day. Is that okay with everybody? Okay. So it's the limit. And I'm going to use delta x this time. Delta x approaches 0 of the cosine of x plus delta x minus the cosine of x over delta x. Now, a long time ago, like last year, Mr. Karsh taught you trig, correct? And he said, if you have two different angle measures, there's a way to expand that, correct? And it looks like this. So I'm going to expand this here. The cosine of x times the cosine of delta x minus the sine of x times the sine of delta x. So that's this thing expanded minus the cosine of x all over delta x. I don't know if you remember that. It's long, long time ago, okay? This is one you don't have to have memorized. I'm gonna ask you to prove this in your notes and you'll just copy it, but I don't think it's bad for me to review that. So I bring it from way in the back to the front for a short period of time. And if you see it again, you remember it again. I had to look it up. Okay. So what I'm going to do is I'm going to interchange this. I'm going to rewrite this one. And I'm going to bring this minus cosine x over here. I'm going to put the minus sine x sine of delta x right here. Over delta x. And I'm going to set this up as two fractions. I'm going to say this is the cosine of x, cosine of delta x, minus the cosine of x over delta x, minus, and here's my other fraction, the sine of x over the sine of delta x over delta x. Because the common denominator is delta x. Would you agree? Now I'm going to go one step further. And I'm going to do some factoring. I'm going to factor out a minus cosine x. And if I do that, this is going to be a minus cosine delta x plus 1 over delta x. And of course, I did not give myself enough room. Minus sine of x, sine of delta x over delta x. So I'm going to do one last thing. I'm going to write the limit as delta x goes to 0. And I'm going to look at this and I'm going to say this is the same as the minus cosine x over 1 times 1 minus the cosine of delta x over delta x minus the sine of x over 1 times the sine of delta x over delta x. So I have 1, 2, 3, 4 limits to do. It's kind of like what William said, hey, you could take the derivative of each of those terms because you're taking the limit of each of those terms, right, William?
Yep.
And that's what I'm doing here. I have 1, 2, 3, 4 things I'm going to take the limit of. Now, delta x is going to 0, so it doesn't affect x. So the limit of this is a minus cosine of x. Now, earlier, I told you what the derivative, excuse me, I'm wrong. I told you what the limit of this was. It was one of your special trig limits. Does anybody remember what it was? Nope.
That one was 0, right?
This one was 0. Minus the sine of x, right? Because that doesn't get affected, times this limit. What is this limit? 1. 0 times anything is 0. So now I'm left with the minus sine of x. Q, E, D. Now, I like that proof for a couple of reasons. One is to review what that limit is and what that limit is, and to show you some algebra technique that you either didn't learn or you probably have forgotten, okay? And I'll do the other one tomorrow. Let's just do these limits. So dy dx is going to be, this is the coefficient, that's not going to change. So I just take the derivative of sine. The derivative of sine, Dana, is what? Cosine. So it's the cosine of x. Bam, you're done. That's all you got to do. And Dana, when I learned that in college, I go, I got this baby down. And then I started to lose hair. Because you know which one I goofed up on all the time? The derivative of cosine. You know what I wanted to say it was, Caleb? Sine. And guess what? It's not. It's negative sine. That's when I bought a plastic baseball bat. And every time I got it wrong, I hit myself with that plastic baseball bat, and I've been doing it ever since. That's why my head's a little bit off in a few spots. What? Yep. Yep. When I had children, it was a good bam bam bat. Okay. So I am going to choose Morgan. Dy dx. We're just going to do this. So see what Raina did up here. What do you think this one will be?
3 cosine x.
Perfect. What's the derivative of this? It's going to be a minus what?
5.
Perfect. What's the derivative of this?
0.
Perfect. Exactly correct. Audrey,
Yeah.
what's the derivative of x?
1.
Perfect.
Right.
Okay, let's see if you're going to lose hair here. What's the derivative of cosine?
Negative sine of x.
Yeah, so it's this. You didn't lose any hair. Okay. Everybody got that? And so one thing I'll have to do is give you a proof tomorrow of, so we did this one. I'll have to do this one and then I'll give you some notes. Okay. But you're guaranteed to get work time for sure Thursday, and the quiz is Friday. And I'll make those changes sometime today on Schoology. Does everybody got that? It may not happen right away. Depends on what my wife wants me to do when I get home. Alrighty. So, Avisters, we're done for the day. I hope you have a more relaxing evening than you did last night. I am sorry to have been that person. So, well, no, I'm not. I'm going to continue. So that's kind of a lie. I'm happy to be that person. Okay. So take care. We'll see everybody tomorrow.